Today I want to talk about the vapor cycle air conditioning system, and specifically what happens to the refrigerant in the vapor cycle system as it turns from a vapor into a liquid and from a liquid into a vapor via the transfer of heat energy. This is an animation of a 5-component vapor cycle air conditioning system. We've got a compressor in the lower left-hand corner, a condenser, a receiver dryer, a thermal expansion valve, and an evaporator. There's a fan above the evaporator which will blow the cold air into the cabin. What I want you to see is as we see the refrigerant train change from a vapor into a liquid back to a vapor again, we'll see the transfer of heat energy. Heat goes from hot to cold, from high to low, relative to the temperatures between two gases. And we'll start out at the compressor with the refrigerant as a vapor. If I were to click the compressor, the piston will draw a charge of refrigerant in and compress it, raising the temperature and the pressure of the refrigerant vapor. It sends the vapor to the condenser, which is similar to your car radiator. It hangs out in the air, and the cold relative air passes over it, taking the heat from the vapor into the air, lowering the temperature of the vapor, condensing it, or changing it into a liquid. From there, the liquid refrigerant goes to the receiver dryer, which acts as a reservoir and a filter, removing water and other contaminants that might be there. Then it goes to the expansion valve, where an orifice sprays a measured amount of refrigerant into an expansion chamber, lowering the temperature and the pressure before going to the evaporator. Now, lowered liquid vapor gets passed through a series of tubes in the air. The air, which is hot relative to the vapor, transfers its heat into the refrigerant, vaporizing the refrigerant. That cold air then is blown into the cabin by that blower fan. From there, the vaporized, heated refrigerant gets pulled into the compressor for another cycle. That is how the vapor cycle air conditioning system